The world has changed a lot, but our education system or our learning system has not changed much. Do you agree with me? Come on, just by using a digital projector or a smart board is not going to bring the change in your learning. Myself, Sekhar, presenting you a brand new and innovative teaching methods which will let you fall in love with engineering, and it will also help you to crack any exam, GATE, ESE, Transpose, Zenko, any state government, central government jobs, any job you can crack it very easily with the help of our 3D animations, live demonstrations, and interacting and interesting simulations, specially designed tools, which will not only clear your concepts, but also let you fall in love with the learning and explore the beauty of engineering. Check the link in the description to get a 365 days free trial course. Yes, absolutely free trial course for 365 days. Check the link in the description. Happy learning and enjoy learning. Now coming to this, a beautiful question. This question is what? Nice. This question is, already took up that, now comes to the explanation part. Okay. The explanation for this, the actual doubt here will be, of course, equation wise you can say, if flux is reducing, speed will increase. So if flux becomes 0, speed will reach to infinity. Okay, this is what the equation says. But how physically you can feel that when there is no flux, there won't be any torque for the speed to pick up to that high value? There has to be some driving force. The twisting moment of force is driving the speed when rotating the motor. Okay, the twisting moment of force is called torque, right? So now, as flux is 0, I can see from the equation, torque will become 0. As torque is becoming 0, how it is accelerating to such high speeds? That's just completely annoying thing. Yeah, somebody I think gave the answers. Not really. If you're not really understood, you need to watch it again or watch it again. That's it. Yeah. In a balanced 3-phase star load with all impedance, say, oh, you're asking a question. Come on. Yeah, I'm asking a question now. You need to answer that. With field circuit open, the flux remains is only residual flux, which is very less, so speed will rise. See, that's what the equation says. But physically, how you're feeling? As flux is less, torque also will become less, isn't it? When the torque is becoming less, then how the speed is picking up? Don't say in terms of equation. Okay. If flux reduces, EB reduces, and IA increases. Okay, I think Upendra has said very interesting point. All of you just focus on that point, what Upendra said. Okay, so I think you got the question right. Now, what Upendra is saying is, if flux is reducing, EB reduces, that's fine. Okay, flux is reduces, EB is reducing, IA is increasing, back MF is reduced, armature current has increased, fine. And torque is increasing, that's what you're saying. Your statement is torque increasing. My statement is, this point is very important, Upendra. You mentioned very good point, but slight extension is needed for that. Slight extension, that's it. I want all of you to tell me that extension part. Okay. So I'll ask a question, then you answer to the question, automatically the extension will be done. Okay. If flux is reducing, now to compensate that flux, accordingly, armature current is increasing, isn't it? The product of these two is a torque, which is constant. If torque is constant, then why it is accelerating? Load is having 5 Newton meter, let's take that. How much is the load? 5 Newton meter. Now, because of the reduction of flux, torque has reduced, that's what I'm saying. But Upendra said, a reduction flux, I think I should write that. Okay. Isko change kar do. What I was saying? Yes. Points is very important. Load torque is how much? Load torque is 5 Newton meter. Okay. Let me consider here, for us to feel it, flux has become half, 50%. Okay, flux has become 50%. I'm just generally saying what Upender meant to say. Okay, flux has reduced to half. This is what my question. Then what he's saying is, sir, current EB as flux has reduced, EB is reduced to how much? Half. As EB is reduced, we know the formula IA is equal to V minus EB by RA. So IA increases. Okay. So as flux is reducing, current is increasing, torque is proportional to phi into IA. So torque, you're saying increasing. You're saying it is increasing. Generally, a common person will raise a question that, sir, it is not increasing, it is maintaining. Okay. Then, if that is a question, what will be your answer? Okay, what will be your answer? Load torque is less than electromagnetic torque. Load torque is always constant. I am saying at a constant load torque, I am doing this change. At a constant load torque, I am reducing the flux. That's a statement I have given. Now, I think things are there right in front of me, right in front of you. Okay. You just have to mix and match these things, then you'll get the answer. I think Upender can make it out. Actually, flux is not zero. Let's not talk about zero flux. Okay, zero flux is, last case. First, you tell me about this 50% change in the flux, reduction in the flux. I mean, half of flux is getting half. The speed has to increase, right? So let's talk about that case. Then we will go further. Pooja, you made a point. 50% of your point is true, but not the remaining 50%. But that's a very good attempt. That's a really very good attempt. Yeah, I want some of your thoughts. Unless you share your thoughts, how it's going to be interactive? Come on. Yeah, share your thoughts. Like, share your thoughts also. What are you doing? Are you doing something? Or just listening to me? Alright, this is crazy. I'll give it. No other comments, I think, from anybody? You want me to complete that, or somebody want to say something? At least this, you tell me. Or you want me to wait? I'll wait then. Ah, shine. Thank you. Oops. Yeah. Shunt field open means residual flux is still maintained and decrement. Wow. Upender, I know you could do that. You're amazing. The statement is started right from the beginning itself. That's true. Here also, yes, he made it. Okay. So what's the point he's trying to make here? Just look at the point he wanted to make. Okay. What's the point? Point is, let me highlight his point. In that important point is, oops. Oh, yeah. That's an important point. This is a very important point, which will give the answer to all of us. Okay, that's an answer. That's an complete answer for the question. Okay, Upendra has even started saying something before, and he finished it. He finished saying it. Okay, now let me complete. At least we got something from our student. That's great. Now I'll finish it up. Okay. Flux will decrease. Sir, you from Vadodara? No, I'm not from Vadodara. Okay, now coming to the answer. Careful here. the moment flux has reduced to half, definitely EB will reduce to half. Why? Why? Because the moment flux has reduced, momentarily speed is not going to reduce because of its transient. That's what somebody was saying. Okay, due to the transient nature, because it's moment of inertia, to be more precise, speed will not change suddenly. Speed will be almost same. As speed is almost same, EB, we know EB is proportional to phi, sorry, not equal to, proportional to phi and n speed, phi into n. Now, n is almost constant, I can say. For the momentary case, I'm saying, momentarily I'm saying, okay, for that particular moment, flux speed is almost constant. So EB is proportional to phi. Phi has reduced, EB has reduced to half. You take some numbers, okay, you take some numbers. Let me consider V is equal to, let's take it as 200, okay. So earlier case, in the right at the beginning, EB1, let me consider EB1 as maybe 190 volts, okay, or maybe 180 volts. It makes things easy for us to calculate, okay. 180 volts. The moment flux has reduced, EB has reduced to how much? 90 volts. Suddenly, momentarily it has reduced to 90 volts. This reduction of 90 volts from 180 volts will, you put that here, means you consider RA is equal to 1 ohm. So 200 minus 90 is, 200 minus 90 is how much? 110 ampere. Current will rise to 110. Can you believe this? 110 ampere, that's huge current. Okay. Earlier, how much was the current? When EB was 180, how much was the current? Just bloody 20 amperes. I put that 200 minus 180 by resistance is 1. 20 amperes. Just because flux has become half, the current has become 110 ampere. It has not become double. Momentarily, the current shoot up to 110 ampere. That will shoot this torque developed within the machine to how much? To very high value. So torque developed is more compared to the load torque, which is just 5 Newton meter. Then machine will accelerate. Accelerating. Machine is picking up speed. Now at steady state, why it is accelerating? It's just because electromagnetic torque is much more than load torque, so it is acceleration. Okay. And as it is accelerating, speed is increasing, so EB will slowly pick up. Okay, so armature current is slowly coming down. Speed is picking up, EB is picking up, armature current is slowly coming down. So at equilibrium point, speed will settle. That equilibrium point is much above the present speed. Now the same thing, if this comes down to a very low value, then this EB will come down to very low value. IA will go up to very high value. The torque developed will be very high. That will very quickly accelerate. Okay. This is what the concept. Hope all of you understood. The point. Keep it in the chat section whether you understood or not. Upendra has made it. Among all of you, Upendra has made this.